Awesome. Okay. Everyone, welcome to class today. So, we're going to be kind of building off of last week's exercise with both spectral indices and also using a little bit of Python. And today we're going to be pivoting to another application of spectral indices. Instead of burns, we're going to actually look at vegetation and I guess more specifically kind of vegetation health and the different indicators that can be derived from NDVI, which is the Normalized Difference Vegetation Index. And so our slides are going to kind of do a brief overview of the topic, and then we're going to quickly pivot into the lab exercise, which is kind of a more hands-on exploration of generating NDVI with another Python library that we haven't covered yet. And then I'm going to have a similar exercise to last week where I'm asking you to read a couple articles. These are very pertinent to NDVI and even the Python library we're using. And then instead of having you do like a GitHub flow like last week, I'm just asking that you put your summaries inside the notebook environment, and the instructions will be clear, I hope, once we go through that. But let's just jump right into the slides. And then, as usual, we'll have open QA time while you all are working on your lab exercise. And feel free to kind of hop off as you finish, or if you prefer working kind of alone in your quiet space, I'll be around until 1. So if you need to like hop off and then come back to ask a question, that works too. So just want to give you all options. But yeah, let's switch over to the slides. And these are linked in the class resource for today, which let me share that in the chat just to make it easy for you all. So I'm going to post this in the Zoom chat. So now if you want to read along because the resolution's kind of crappy, go for it. Sorry, I've been trying to figure out ways to do this to improve, but it seems like there's a limitation with using Zoom and OBS, so I'm going to keep looking. But if it's really grainy, then I would just encourage you to look at the slides on your own screen or the recording after the fact. So today, we're going to be continuing our kind of exploration of spectral indices. And like I said before, we're going to switch to another application, and we're going to kind of focus in on the Normalized Difference Vegetation Index. So just to give you kind of an overview of the lecture lab flow today, we're going to briefly discuss, like very briefly, remote sensing of vegetation, then kind of hone in on the Normalized Difference Vegetation Index, and then we're going to jump over to the lab where I'm going to, like last week, kind of demonstrate the flow of what you need to do, and then I'll kind of let you all loose to get started, and then just be around to kind of support you with either troubleshooting or just general questions. So as always, don't hesitate to unmute yourself and ask a question. I'll try to follow the chat, but I think in general it's easier if you just unmute yourself. But every so often I'll try to check the chat as well. All right, so the remote sensing of vegetation. So last week we were touching on an aspect of vegetation, which is burns. I mean, vegetation is not the only thing that burns. Like buildings can burn. I mean, often they're built out of trees or dead trees, but this is kind of another stage of the life cycle of plants. You could think about burns as kind of the one drastic extreme in certain landscapes where plants ignite. But there's many use cases and applications where you need to monitor plants before they're totally dead and combusting. And so in California specifically, because I assume that's where most of us are currently living or even maybe from, we have a wide variety of vegetated landscapes, like stupid diverse, in a good way. But just thinking about kind of the landscapes on this image right here, where we have kind of temperate rainforests, more looks, I guess, like alpine kind of mountain forest. And we have high desert with Joshua tree, coastal landscapes with kelp forests, almost like grassland prairie, and then what seems maybe like an alpine kind of above the tree line situation. And so from the perspective of like a sensor or even a single index, I want you to just maintain that awareness that one size doesn't necessarily fit all, whether it's a sensor or a kind of index. It might not necessarily work everywhere. Um, there's limitations with all of these technologies, and it's kind of hard to share a like blanket statement. And so I think that it's important to just maintain awareness that you can't just apply these things without thinking about limitations like that. And so we're going to discuss a little bit of that today, but then the articles that I've um, included in part 2 of the lab really discuss some of the limitations of these indices, and even touching on how um, issues like spectral resolution or the pixel resolution can even impact how the index works. So yeah, just always do your research and check if others have done something similar to what you're doing. Like if you're looking at grassland vegetation change, see if others have done something in grasslands, and don't just try to apply something from temperate rainforests and hope that it works. So we're gonna now kind of hone in on one very specific vegetation index. There's dozens and dozens of vegetation indices, but I'd say NDVI is one of the like OGs and still pretty heavily used throughout research, government, industry. So I think it's a useful place to kind of anchor yourself and then start your more maybe niche index endeavors. And so the normalized difference vegetation index is really just a measure of the amount and vigor of vegetation on a land surface. If you think about that like, what does that even mean? And I think that that's kind of getting at what NDVI is really measuring. It's not necessarily measuring how much mass there is of plants, how much photosynthetic activity is happening. It's kind of this like proxy measurement that scientists and researchers and engineers have used and kind of correlated with more on-site local measurements to then extrapolate and generate these useful indicators. And so at high level, NDVI is kind of used as this measure of plant health and photosynthetic activity, but I'd encourage you to, as we read through the articles this week, dive deeper and see that it might be a little more nuanced than that. And I'm not expecting you all to become like plant ecologists. That's really not the point of this, but just to think about how NDVI may or may not be useful in your application. And so NDVI is just very similar to the NBR index that we were generating last week. Instead, we're using the near infrared and red bands of our sensor. And so depending on the kind of biophysical health of at a current time, plants kind of exhibit different NDVI values. And so in this little kind of clip art caricature diagram, you can see that the more green looking plant exhibits a higher NDVI as compared to the more kind of wilted senesced plant that looks more in like it's in the stages of fall. And so you can use these NDVI indicators to really measure maybe where a plant is in its life cycle. Sorry about all the beeping. Let me mute my phone. Cool. And so NDVI is used as kind of an indirect measure of a lot of these biophysical phenomenon, including like cumulative effect of rainfall on plants over a certain period of time. You can see how that might be important in a place where they're growing crops, wanting to kind of measure the impact of rainfall on yields, perhaps even how much livestock you can manage over a certain area of land in the case of rangelands where they have herds of animals. yeah, and then even susceptibility to certain pests and how the, I guess, vigor of a plant could lend itself to either resisting or being more prone to like beetle infestation. And so um, NDVI has been used in a lot of different applications, and the articles that I've assigned for this week will definitely cover many of them. But before that, we can also kind of do a quick overview. I guess this figure, it's a bit messy, but it gives you an idea of how NDVI can be used in more complex applications where you're not just using it as a snapshot at a single point in time, but instead using it uh, multiple NDVI data points through time, and you can kind of create these more complex indicators of plant health, seeing how fast it reaches its maximum greenness or how slow it senesces, seeing maybe how long the season is of greenness and how that changes through time, and correlating that with broader environmental factors like rainfall or even uh, sun. And so I think that NDVI it's a fairly powerful indicator if you use it in a more kind of time series data set context. And these are just a few of the uh, kind of potential use cases. And I believe these are straight out of the article, but there were more as well. But you can look at things like annual production of vegetation, comparing vegetation biomass across years, or even how fast spring occurs or fall happens, when spring happens, and it's talking about how many days food is available for animals in an ecosystem. And so NDVI is used in the context of, I guess, agriculture. It's used for ecology. It's used for forestry. This indicator is it's a pretty broadly reaching analytical tool, and so um, that that's kind of why I positioned it as our starting point with vegetation indices, but also it is not the end all be all. And I encourage you all to look at alternative vegetation indices, especially with different kinds of sensors, particularly like UAV sensors that have different capabilities than Landsat. And so that's always something to consider. And so um, I guess this is more of just like a thinking point for you all as you move through this lab and through the rest of this course, to be honest. But what are just some of the potential measurement limitations you could think of in different landscapes? And this is something that will be discussed in the articles, but just kind of pivoting back to our overview slide with the different biomes in California. Um, I think that in a place like this grassland here, it's pretty homogeneous. There's patches of variation, but it's a pretty flat green expanse. And so you might be able to get away with using a coarser resolution sensor. Whereas in the case of Joshua Tree, I could see where having finer resolution might be helpful, especially when there's such a mixed landscape of rocks, bare earth, trees, shrubs, grasses, even in this kind of higher elevation area. I think that thinking about things like spatial resolution, spectral resolution, radiometric resolution, I think that that's important. And I just would encourage you all to just keep that in the back of your mind whenever I introduce one of these indices, or you just come across one in your readings for this class or for your master's degree project, or even when you're working in industry full time again. And so that's really it for NDVI slides. I think that the articles do a really good job of laying some additional context for the, I guess, scientific foundations for NDVI, and then the actual applications in different industries and research settings. And so at this point, I just want to jump over to collaboratory. And this will be available in your course overview. And let me share that in chat as well. But it's kind of similar to last week. We're going to be using Python to kind of explore the creation of spectral indices. We're also going to do a bit of classification this week. And then we're going to finish off with some reading to kind of pull it all together. And so this is also kind of our first foray into image classification. And to give you a teaser, we don't have class next week, but then the following week, we're going to do another more, I guess, involved image classification lab exercise. And so hopefully you all will get excited for that after this one. But this is very basic kind of classifying. There's no machine learning or anything in this lab, so don't freak out. You'll see as we go through that it's nothing too wild. But I'm going to open this in Collab so that we can actually run these cells. So today we're going to be plotting combinations of raster bands, similar to what we did last week. And then we're also going to be calculating, classifying normalized difference vegetation index results. And today we're going to be using the EarthPy Python library. This is a library built on top of raster.io and other foundational kind of GIS Python libraries. And so honestly, the user experience is much easier than that of using raster.io by itself. And so I wanted to kind of show you another option in the raster GIS realm for free and open source Python tooling. So I believe the EarthPy tool is built out of either UC Boulder, like Colorado Boulder, or Santa Barbara universities. It's like a project built out of one of their labs. And so it's a pretty cool tool set, and it simplifies a lot of the aspects of dealing with rasters and calculating them as compared to using Rio or raster.io. And so I'm going to skip over the relevant course objectives, but if you're curious, feel free to kind of read through these. But I'm really interested in kind of blending spatial analysis, doing some research, reading, and communicating your results in written format, just to kind of prepare you for a final project in this class, and then even your final degree project and any kind of presentations you might have in your careers. And so the main lesson goals are going to be to calculate and classify a spectral index derived from satellite imagery data. We're going to be calculating NDVI and using Landsat 8 data. And then we're also going to be using programming to automate an applied remote sensing task, namely calculating NDVI and classifying it. And we're going to be using EarthPy and a couple other perhaps familiar tools from last week, but you'll see very shortly. And so I'm going to skip over this data source section because I encourage you to read this as you're working through the lab, but it's really just some background information on Landsat 8 that I got from the USGS docs and information about the sensors on that satellite platform. And today we're going to be using predominantly band 4 and 5, red and near infrared, but we're also going to be using red, blue, and green to visualize a bit of true color imagery as well. And each of these bands, you'll notice, is a 30 by 30 meter pixel size, and they have different wavelengths at which they're collecting information. And then finally, to kind of give you the formula again for quick reference, we have the NDVI formula and what it maps to when you're using Landsat 8 or 9 data. So this should empower you to complete the whole lab, to be honest. And like last week, I'm not really expecting you to generate any Python code from scratch. It's kind of like running through existing code and just kind of learning that way and tinkering on your own if you're interested. But I tried to be pretty diligent about including a lot of links this week. So whenever I'm using a particular library or a particular function, I'm really trying to link it so that if you want to learn more, you can. But I know that for many, that's just like way too overwhelming and just like noise. So it's more just if you're curious, feel free to read the docs and see how we're setting this up. But yeah, first things first, we got to install EarthPy. We're using Collab. So if you're running on your own local computer, you might not have to do this step if you already have EarthPy, but because we're using this kind of cloud-based Python environment, we have to install this every time. And if you want, follow along, but honestly, it's probably better to just like sit and watch, and that way you don't necessarily get lost. But if you'd like to follow, feel free and have fun. I think that's important too. Got to have fun when you're learning. And yeah, so this will take another few seconds. Just installing EarthPy, and you can also see some familiar faces from last week, Raster.io, and yeah. So now that we have Raster.io installed, let's import the packages we're going to use to, I guess, display our data, like kind of in a plot, and even the EarthPy libraries that we need. And so we're going to use the OS operating system module, which is useful for kind of dealing with file paths, the glob library, which is helpful for kind of dealing with file names that might be similar. So if you're dealing with like Landsat data where there's like 10 bands and you just want to get all of them with a similar kind of file start, but not specify a specific band, you can use glob for that. We're using NumPy again for array math. We used that heavily last week. And then matplotlib for visualizing our data. The listed color map function will help us kind of create color maps on the fly with colors that we specify. And then a bunch of EarthPy functionality, mainly the main EarthPy. And then the spatial is a kind of tool set for generating or doing raster math. And then EarthPy plot will help us with some plotting. Cool. And so this week we're going to be using some Landsat data, but EarthPy also gives you access to a variety of different data sets across different sensor types. So I encourage you to play around with this and have some fun as kind of an easier way to explore data sets with programming. And so it looks like there's some LiDAR data, there's additional Landsat data types, some true color NAIP stuff. So I encourage you to check this out in your free time if you're interested. Oops, don't need that. Okay. But today we're going to use the Landsat 8 dataset, which they title Vignette Landsat. EarthPy is really great because they provide you some data sets right out the bat to like explore and learn with, but then there's some helpful functionality to actually download additional data set. It's in the docs, so I encourage you to look into it if you're curious about practicing more with Python, but if not, no worries. So we've downloaded the Landsat data, and it's now in this location on our computer called Root Earth Analytics Data Vignette Landsat. So I'd like to see the contents of that directory. So I'm going to use the ls function. And so this is something we did last week pretty extensively. And you'll notice I'm using the exclamation point again. So we're indicating this is not a Python function. This is a kind of a Linux command line function. And so you'll notice that we have a bunch of data. And so that's great. All our data is here as expected. So to start, let's change our working directory. This is kind of something that I believe people do in using like Envy or Esri software, where you want to set like your working directory for this project. So you can do a similar thing with Python as well. And so instead of having to every time point to this root earth analytics data Landsat, we're just going to specify this Earth Analytics folder as our home directory for today. Then we're going to kind of create a stack of file names. And so this is what I was mentioning before about glob. This lets you kind of pass in a bunch of file names, but then you can strategically leave out a character and replace it with some kind of wildcard, like an asterisk. And then you're telling Python to kind of look for any file that matches this pattern, but the band number can be anything, basically. And so we're going to be kind of picking up bands 1 through 7 and storing them into this variable. Then we're going to sort that array so that we make sure it's in order, band 1 through 7. And then we're going to use a EarthPy helper utility called stack, which lets us take a list of file paths and stack it into a NumPy array, which is super convenient for us. It's essentially creating a multi-band raster image for us. And then we're also passing that we want the no data value to be -9999. Awesome. And there's no output because we're just kind of running some mathematics and not asking for any data to be displayed. But now we have this multispectral image in our memory in Python, so we can actually plot it if we want. And so to start, let's plot just the true color RGB image and see what that looks like. And so you can see this looks a little better than last week. It kind of renders a lot more nicely than raster.io out of the box. And so we're able to display our data set. We can also render kind of the false color infrared image using the same plot RGB function, but instead of passing 321, we pass 432. And you can see now the data is rendered totally differently, same features, but we're not seeing the same colors as before. And so this is something you'd kind of traditionally maybe do in a more graphical user interface GIS, like ArcGIS Pro, ArcGIS Online, Envy, Erdos, you name it, QGIS. But you can do all this in Python too, or it's not just Python either. You can do this in many programming languages, but just trying to show you that you don't have to use like drop downs and click on things. You can automate stuff too. And so this was a quick just kind of building off of last week and showing you that it can be easier to display data. And then now let's actually move on to calculating our NDVI. And you can see it's a pretty short one-liner. We're again using one of the EarthPy or the EarthPy spatial package. And then we're using their normalized diff function, which calculates a normalized difference kind of index for you based on 2 data layers. And so we just have to specify which layers. And for us, that's band 4 and band 5. Just note that Python counting starts at 0. And so band 4 would be, I guess, number 3. And then band 5 would be number 4. Just so you know that. And if you're wondering why I'm not passing band 4 and 5. Cool. So we have our NDVI data calculated. That took like less than a second. Super quick. Let's plot that data. Awesome. So we generated NDVI from Landsat imagery. Now let's try to classify this data. And you'll note that it's kind of just a range of values. There's some pockets where it's pretty green, and then there's pockets of kind of like bare. Some of this overlaps with clouds, but then also some of it's just kind of this empty space. So that's interesting. And so this calculation, we're not really concerned with these clouds because this is really not like what I call a production analysis. But if you were doing a more, I guess, potentially serious analysis, you might want to consider the impact of these clouds on your data set and how that can skew results. but today we're not going to worry about that too much. All right, so we have our NDVI data set. Now let's classify it. So we have some bins that we're going to create. And so this is where we're not going to interrogate the data and try to like find where the natural bins are kind of forming. We're just going to impose these kind of classes on it and just classify this data set and bin the values into these categories. So the first bin will be from negative infinity to 0, then from 0 to 0.1, from 0.1 to 0.25, 0.25 to 0.4, and then from 0.4 to positive infinity. And so we're going to discuss the actual category names at the cell below, but just know that we're going to kind of bin our data into these NDVI categories based on these kind of NDVI numbers. And this NumPy digitize function just kind of lets you really just check where the data, which class it belongs to. It's kind of like a lookup kind of functionality for you. And then using that NDVI Landsat class lookup, we're going to apply this kind of mask to our data set and generate some unique classes. And so this didn't actually save into a usable variable, these unique classes. So now we're gonna save that into a variable for our plotting. But you can see that we have these 5 classes and then this kind of empty class. So the colors don't really matter, but it's kind of nice for visualization's sake. But this is where I was previously mentioning the listed color map function lets you generate kind of a color ramp from colors you provide. And so we're just trying to do kind of a gray to green gradient. And our categories are going to be no vegetation, bare area, low vegetation, moderate vegetation, and high vegetation. And so these kind of correlate with the numerical categories that created up here. So negative infinity to 0 is going to be no vegetation. Technically, our data doesn't go to negative infinity. It's most likely just to -1, but this is just for NumPy's sake to pass that. Similarly, bare area will be in this kind of 0 range. And then as we increase in NDVI value, we're going to have more and more vegetation cover. So you can see this is a very simple kind of algorithm for calculating how much vegetation is in an area. There might be better ways to do this, but maybe we'll talk about that next week or in the following weeks. This is kind of like a phase 1, like how can you, the most simple way to categorize things. So we're reusing our NP unique classes that we generated previously here, and we just kind of printed it out. Now we're going to save that into a variable called classes and make a list out of it so that we can use it for visualizing our data. And then we're going to just remove that last value of none that we don't need, the one that's right here. So now we're going to really just plot the data. And we're using PyPlot, which should be similar to you all or familiar to you all from last week and even from previously today. And then we're just going to show this image and apply the color map that we created. We're also going to add a legend, and then we're going to specify a title and some font sizes and really just some niche like formatting things that are not particularly important. But you can see that we have a classified NDVI data set. And so just right off the bat, I can see that there's some potential errors with this where because we did not consider those, or we did not manage those clouds, they're coming up as this kind of low vegetation area or even bare area. So that's just something to remember when you're working with these sorts of data sets, just to remind you, this is kind of where those clouds were, and they're coming up as not clouds here. So just important to note. So we ran through this whole kind of classification process, but it was a lot of like running individual cells kind of not the most streamlined process. And so I did a little bit of code refactoring to make the user experience a little nicer. And so this following code cell is really just taking those the individual lines and packaging them into a Python class and then a function to run everything. And so I encourage you to read through this, but I'm not going to really like dive too deep because this is more like Python side of things and less on the applied remote sensing. But there's nothing new in here other than I'm repackaging all the code from above into a Python class. And so if you want to run everything and generate all of that data, you just have to use this run everything function now and pass all these ugly input parameters. And so I got to specify things like the data directory, the file name glob, no data value, all the stuff that we kind of were doing line by line. And now it's just this single big function that if you run, should generate your NDVI data set with your name or your email, and also the classified data set with your email. And so you don't have to run through all of those steps. And so this is kind of getting you to think about automation in different ways where imagine you were running some different experiments and you're wanting to test different classification schemes or even different algorithms. Having to do this manually is so annoying. And you'll probably mess up just because that's human, or you'll forget which ones you did. And so if you can just automate all this and then just store what you ran in like another data set, it simplifies everything. You can go and get a coffee while the computer is doing the work for you. Life is good. And so that's kind of what I'm trying to encourage you to think about more, getting ways, or how can you use computers to simplify your life a little bit so you can go get a coffee and take a little break. Before the lab today, which I believe I highlight below, the main change I want you all to do is to update this run everything function with your actual CSULB email. So it's not just outputting my email. And that way I know that you are kind of reading through the code and understanding what you need to change to get the correct results. And so for part 2, so that's down below in the deliverable. And so part 2, we have some article summaries, which kind of similar to last week with the 2 to 4 sentences. Don't use something like ChatGPT or a large language AI model, but instead of having you submit a JSON file, I just want you to update this code block and write your summary right here. It should be a lot easier, and there shouldn't be problems with Git. And this will give me a chance to create that kind of Git flow resource to share with you all to help empower you to do more Git stuff in the future. And so there's an article about using satellite-derived NDVI to kind of monitor environmental change, or to monitor how ecosystems are responding to environmental change. So that's the oldest article. Then a newer article is kind of about EarthPy and understand. It's a pretty short one. It's a couple pages only. Just understanding the inspiration for EarthPy and what it can be used for. And then finally, kind of this review article that's kind of discussing how NDVI has been used from the 80s until 2021. And so I think that's an interesting read on how this index has, or the uses of this index have evolved through time, and how it's still being used even today after 30-something years. So that's pretty cool. And then for the part 3 of this lab, it's kind of starting to get you to think a little more about your project for this class and also a little more GitHub. And so just having you add me as a collaborator to the repo you created during Lab 0. I included the steps here. And then this link goes to a GitHub resource on how to do the same thing. I basically kind of copy pasted from there, so you don't have to go there if you don't want to. But these steps should just work. And I'm here if you run into issues. And then create a new item in the project you were asked to create during Lab 0. Essentially kind of creating an issue, but it's a slightly different workflow. And I've included the steps here. and then I will respond in a comment about next steps kind of over the coming week. And I just encourage you all to rest and enjoy spring break. And that's really the lab assignment. And so the deliverable for today or for this week is uploading this Python notebook with your written responses to the repo that you created during Lab Zero. And then posting a new comment with a link to that notebook on the issue that you created during Lab Zero so that I can take a look. And so that's really it for today. I encourage you to just like jump in and start. But if anyone has questions, I'm here to kind of hopefully clarify that for you. And yeah. Sorry about the barking. My dog is pissed.
Yeah, so I wanted to ask, is all the information eventually going to be on Canvas, or is it all just going to be on GitHub?
I was planning on keeping it on GitHub, but I can push it to Canvas if that helps you all. The main hesitation with Canvas is I know that people lose access after they're not students. And so I kind of wanted to keep it so that you could reference this down the line if you wanted to. But I can certainly like link this in Canvas if that helps.
Yeah, just 'cause it's like everything else is on Canvas and it's just easier to look at it through Canvas, but no, I understand the open source aspect of it though.
Yeah. Yeah, I'm about having learning materials be free and available. But yeah, no, I feel you. The convenience factor.
I had a question about the project.
Yeah.
Do you have any guidelines for what our
Yeah.
project will include or have? I'm just thinking of planning ahead.
Yeah,
Yeah.
totally. So that's where I'm going to share that in the comment or I guess in part 3 of this lab. I will be sharing that over the coming week with you all, kind of the guidelines and even like a resource on how to help you narrow in on a topic if you need help. So that's coming soon. Um, that'll be, I'm going to quickly scroll down, so I apologize. But in part 3, I'm asking you to create an item in your GitHub project. This is where I'll comment with next steps about the final project.
Okay, thank you.
The guidelines with you all kind of individually just to make it easier for all. Yeah, in terms of the projects more generally, I'm not interested in making it like a huge time sink or commitment for you all because you all have lives and other responsibilities. But I think it's a valuable opportunity to kind of just practice and improve and uh, learn about new things. So I guess I'd say don't be too stressed about the final project. I really want it to be more of just like a learning experience and also something you could potentially share in your portfolio with others about what you've done or what you're curious about. So yeah, uh, I'm much more interested in adding value that way than like assigning you a bunch of work that is annoying.
Alex, sorry, I missed the beginning of class. Is this going to be uploaded to YouTube later?
Yeah. So I'm recording this. I'll stop recording maybe at like 11, depending on how many people are around. But yeah, I'll upload it and share it in an email like last week. And then I'll also post the link on the course webpage. So this will be updated probably tonight or early tomorrow morning with the link to the recording.
Okay, thanks.
Yeah, you're welcome. And if anyone has issues accessing those YouTube videos, let me know. I think they're unlisted, but they're not like private, so you should be able to view them if you have the link.
Alex, unfortunately, I got to bounce today early because I have an errand I have to take care of.
Yeah, no worries.
Or if I have a question this week, are you available? If I need to send an email, maybe we can connect via Zoom.
Yeah, totally. Yeah, I can. I think it's in the course website, but yeah, we can schedule appointments, and because I don't have like office hours like traditionally, like because there's no office. But yeah, if you need to, we can schedule something on Zoom. For sure.
Okay, I appreciate your time. Thank you.
Yeah, dude, have a good one. See you later. Where in Costa Rica, Cameron? That's pretty epic.
Hey, so Alex, I wanted to ask you a question real quick.
What's up?
So we have a Discord that we use to like talk to one another.
Yeah.
Did you want me to add you to it so we can like ask you questions directly on Discord?
Yeah, sure. I mean, I don't want to like intrude on your like student only Discord, but yeah, that's chill. I'll give you my Discord handle. Give me a second.
Yeah, we also have Dr. Steinberg and Suzanne on it, so
Oh,
no
cool.
worries.
For sure. Yeah, no, I'm on Discord most of the time for crypto non GIS stuff. So that'd be super convenient to be honest.
Yep.
Okay. When worlds collide. That's funny. Okay.
All right, I'll add you.
I feel you, Anya, on catching up on labs. Yeah, that was like spring break for me in grad school too.
I also posted a link in the chat
Oh, cool.
to join.
Sick.
Yeah. And we have like a dedicated channel for remote sensing.
Okay. Oh, cool.
Alex,
Hey, what's up?
I just have a quick question
Yeah.
because I missed last class and I'm kind of like trying to go through the recording to see if you answered this question, but I don't know. I don't know if you did or not. But I'm trying to get started with this Google collab and I'm just wondering like what's the best way we should set it up. I see that there's like a way that you can link your GitHub URL in there. Should we do all that or should I just like open a file and start it up?
Yeah. I kind of avoided the linking with GitHub because I know it can be annoying sometimes. So if you want to go for it, but you don't have to, I'd say that the flow that I've been having students follow is, I mean, you need to get a Google account. And then, so you just can open, if you click like this button here, can you see my screen, by the way? I'm not sure. But
Yeah, I can see it.
so this will
I
open in Collab in your Google account, and then you should just be able to run things. And then when you want to upload it, just download like an IPYNB and then add a file in GitHub. So you don't need to like sync your account because I know that I've seen it mess up for some people. So I just didn't want to bother with it.
okay.
Does that answer your
And then
question or not?
yeah, that does.
Okay.
And then like when we're um uploading this to our project
Mhm.
on GitHub, should we just like
Uh,
copy it?
so okay, so like, so basically, once you download this file, so say we'll download it or whatever, and then imagine this is your repository. You know what I mean?
Mhm.
Go and just do add file, upload file, and then you would navigate to wherever that file is. You know what I mean?
Okay,
So that,
got it.
yeah, that's the flow. Yeah.
Okay, thank you.
You're welcome. Oh yeah, and so if you have questions, feel free to reach out to me on Discord too, because Axel added me. And feel free to add me too if you want as like a friend or whatever to uh, ask questions. But also, if you just need to, you can tag me in like in the remote sensing channel if you have a question, and I can get back to you that way too. So I'm pretty flexible on reaching out to me. So whatever works, to be honest.
Hi, Alex.
Hey, how's it going?
Hi, good. How about you?
Good. Not too bad.
Did you say when the lab is due?
I did not actually. So, hmm. Do you technically have class or let me check the calendar real quick. Give me a second.
Thank you.
Yeah. Yeah, that reminds me. I'll like send an email blast to the class about the actual due date because I don't think I included that in the instructions. So thank you. Yeah, I mean, so I guess it's a little longer. So as long as it's done before April 8th, before class, we're good. But I'll blast that out to the class too.
Okay, so April 8th at 9 a.m.
Yeah.
The right before class.
Yeah, before class.
And that's how all the labs are going to be due, just before the following class?
Yeah, for the most part. Yeah, that's kind of just the flow. Because I know like things come up and sometimes people will just wake up early on a Saturday to finish things. And I'm not going to judge if that's the case.
Sounds good. Thank you.
Yeah, you're welcome. And I'll include that in the email with the session recording link for today. The due date. Yeah.
All right, thank you.
Yeah, thanks for the reminder too.
Hi, I just got a notification from Canvas about the assignment. Just to clarify, we don't have to actually download anything onto Canvas, right?
No, yeah, one of the students asked, so I created like kind of placeholder assignments, but everything is still on GitHub. You know what I mean? It's
Okay.
really, there's no submission you have to do on Canvas. It's really just linking to the instructions and then,
Okay.
yeah.
Thank you.
Yeah. No, you're welcome. Everything going all right for you all? Just checking in.
Hi, Alex.
Hey. Hey.
Can you make sure that I uploaded my repository underneath? I'm just a little confused if I did that correct.
Yeah. What step are you on, or what are you doing right now?
No, actually, it was from the last lab. I finished it yesterday, but I'm not sure if I
Okay.
uploaded it in the right repository. I can show my screen.
Sure. Yeah.
It's a little confusing. Are you able to see it?
Yeah, I can see your screen.
Okay. Because there's this one, and then I uploaded to mine. Let me see.
Oh, so
For the first part of the lab, are we supposed? Why I uploaded to this one? Were we supposed to do that or?
let me go back to the. I don't remember the lab
Okay.
instructions, to be honest. It's been a minute. Give me a second. So yeah, you actually have to upload it to not this not this repo, but your repo.
Okay, I had done that initially, and then I started like scrolling down, and I started seeing like JSON from other.
So yeah, that's part one, but then part two, you got to upload it to
Oh
my
yeah,
repo. Yeah.
Okay, so that's why I was confused. For part one, was it to add the file within this?
No. So part one, it's add the file to your repo. So it would be
I
like
did that.
Iris
Let me see.
Diana 00 / whatever.
Yeah. Oh, where is that?
The one I asked you to create during lab 0.
I guess it's projects. No, those are your
No. So
projects.
if you go to your yeah, go to your repos. Yeah.
So I have this
It's
one,
that
and
one.
then right here,
Yeah, that's where I want part one, upload it there.
part one.
Yeah.
Okay, and then for part two, it was going into.
My repo, the one you were at previously. That's where the JSON goes. Yeah.
Oh,
Yeah. So I think you were right. I think you had it fine.
okay, let me see. Is this correct?
Let me check. Did you
Those branches, and then
Iris Flores, the JSON? Yeah, that looks fine.
okay, maybe I was overthinking it.
Yeah. I mean, it's a little overwhelming, to be honest, at first, but yeah, I think you might have just been like overthinking it. But yeah, like, no, you're good.
I always do. So
I feel no, there's nothing wrong with it. But yeah, no, I think you're good. And when I go through it, like, this is more like I'm not really trying to grade you all aggressively on like GitHub stuff so much as just expose you to it and like give you an opportunity to learn that you might not otherwise have. And so just trying and engaging is more important than like it being 100% perfect. You know what I mean? And so I'd rather just show you like, oh, you missed this one spot, and it's not like points off so much as just like next time try to
Okay.
do better. Yeah. So yeah, no, I think it's fine.
Okay. Yeah, I've used GitHub before, but I've never like it's never been to this like
Yeah.
extent.
No, I feel you. Yeah, it can get deep pretty quick.
Mm.
Yeah.
Okay, thank you.
Yeah, you're welcome. Thanks for checking. But yeah, if you ever have questions, just reach out.
Okay.
I'll be right back. I'm gonna get some water, but I'll be gone for like a minute. Are you all cool if I stop recording and begin the upload process, or do you want me to record for a while? No pressure either way, just because it's pretty quiet. Figured I could stop recording. All right, I'm going to stop the recording.